Every group is isomorphic to a group of permutation. This statement represents Lagrange's theorem, Cayley theorem, Fermat theorem, or fundamental theorem of group. This is direct statement of Cayley theorem, which says that every group every group is isomorphic to a permutation group that is subgroup of a symmetric group. This is direct statement asked in exam. And what is Lagrange's theorem? Lagrange's theorem is order of the subgroup divide order of the group. This is the statement, or its corollary, you can say result, says that order of A is also divide order of G. A cycle of length 2 is known as transposition, orbit, circle, none of these. A cycle of length 2 is known as transposition. And number of transposition tell us permutation is even permutation or odd. If number of transposition comes a even number, then even permutation. If number of transposition comes odd number, then that will be odd permutation. Suppose write permutation in disjoint cycle. Suppose this is disjoint cycle 1 3 5 4, then write its permutation, sorry, transposition 1 with 4, 1 with 5, 1 with 3, 1 with 4, 1 with 5, 1 with 3. These are transposition, and this transposition 1 2 3, 3 transposition, and 3 is odd number, so this permutation is odd permutation. So we decide permutation is even or odd on the basis of transposition. Let sigma be an element of the permutation group S5, then the maximum possible order of sigma is. We know that order of an element of permutation group, symmetric group, using 5 symbols. S5 symmetric group of 5 symbols. This is a permutation group, and we know the order of an element in permutation group is LCM of disjoint cycle. LCM of length of disjoint cycle. Length of disjoint cycles means if you have any permutation, write that permutation in disjoint cycle, and element of the permutation, order of an element of the permutation will be the LCM of disjoint cycle. So this is S5, and order of Sn, normally order of this Sn is n factorial, means order of symmetric group is n factorial. But here is not asked about order of the S5 or Sn, here about order of an element. So partition of 5, 3 plus 2, this why we are doing partition of 5, because disjoint cycles have combination of 5s, combinations of cycles. Suppose this is 3 length cycle, this is 2 length cycle, so LCM will be 3 comma 2. LCM of 3 comma 2 is least common multiple is 6. So disjoint cycle have the length of partition of 5. That's why we are doing partition here. 3 plus 1 plus 1, 4 plus 1, 2 plus 2 plus 1,
2 plus 1 plus 1 plus 1, 1 plus 1 plus 1 plus 1, and last one is 5 only. So there are 7 partition, 1, 2, 3, 4, 5, 6, 7. Partition of 5, we have 7 in 7 types. So element having order is equal to LCM of 3 comma 2, this is 6. LCM of 3 comma 1 comma 1 is 3. LCM of 4 comma 1 is 4. LCM of 2 comma 2 comma 1 is 2. Again LCM of this one is 2. LCM 1 and LCM 5. So maximum LCM is possible 6. So order of an element with maximum possible order is 6. So option B is correct.
A cyclic group of order 60 has how many generators? This is question, very easy question. In a cyclic group of order n, then or there are phi n Euler-Toten function. This is Euler-Toten function phi n generators. Using this concept, number of generator of group having order 60 will be phi 60. Prime factorization of 60 is 15, 4 is 60, means 2 is square into 3 into 5. It will be 5, 5, 2 is square into 5, 3 into 5, 5. Or you can solve further. 60 into 1 minus 1 upon 2, 1 minus 1 upon 3, 1 minus 1 upon 5. This give you 60 into half into 2 by 3 into 4 by 5. 2 cancel out by 2 and 3, 5 is 15, 4. 4, 4 is 16. There are 16 generator, means option C is correct. The number of abelian group of order 24 up to isomorphism is. This problem asked in two different way. One way is written already, and second way is find the number of non-abelian group or says up to isomorphism of order 24. These are the two ways to asking questions. So number of abelian group of a specific order, number of abelian group up to isomorphism or non-abelian group of a specific order of order something can be easily find as order of G is given 24, and we can write 24 as a 2 raised to the power 3 and 3. 8 3 is 24. This is perfect. These powers either 3 or 1 normally known as Ni. Ni means prime powers. So number of non-abelian group of order 24 will be product of partition of Ni when I is running from 1 to R. Here R is 2. So partition of 3 is 3. How? 3 can be written as 3, another 2 plus 1 or 1 plus 2, and last one is 1 plus 1 plus 1. So there are 3 way to write partition. And partition of 1 is 1. So 3 into 1 is 3. So option C is correct.